previous class, we saw the definitions of object and class. So we will continue the concepts of object-oriented programming. Now the next concept is abstraction. What is abstraction? Abstraction, data abstraction means hiding the internal details or hiding the implementation details. I will tell you an example to understand this concept. After finishing your degree or your PG, you will be given a project to do, right? Something like project work. Then at the end of the project work, you're asked to submit the project report. In that project report, we in the starting pages or in the first page or second page, we write an abstract. There, that the meaning of that word abstract means just the outlines of your project, not the internal details, but just the outlines. So in that way, data abstraction means hiding the internal details by just giving the outlines. That's all. To understand this concept of abstraction, let me tell you one more example. If you go to China or some other foreign country, then if someone asks you, where are you coming from? Then what will be your answer? You don't say I am from Greenspat or I am from Chittoor, right? Because those people, they cannot understand where this Chittoor is. But what do you say? You say that I am from India. And then from in this country India, from which state? Andhra Pradesh state. In Andhra Pradesh, which district? Chittoor district, or something like that, you'll tell. So this is what we call generally abstraction. In the first question, you are just telling you are from India, means high level of abstraction. You are not giving your internal details, right? Then in the second question, a little bit lower level of abstraction. You are from Andhra, and still another lower level of abstraction. You are from this district. So this is just a small example of abstraction. Then to understand this data abstraction, I think this example will give you some idea. Now we'll see data abstraction, encapsulation, and some other concepts of object-oriented programming. Now we will continue discussing the basic concepts of object-oriented programming. In the previous class, we covered certain things like object and class. We saw the definitions, and now we are going to see the remaining object-oriented programming concepts. This is what we saw in the previous class. Object, the definition of object. I said an object is a real world entity. So it must be an existing entity. So we took table as an example, right? Then in that table example, we saw that the table has certain attributes. So every object has certain attributes, and we can do some operations on the table. Here, object is equal to data plus methods. So I already told you that these words data can also be represented as attributes, right? Then methods means operations. That's what we saw in the previous class. What we can write is an object is equal to attributes plus operations, right? Then both are same. Attributes means data and operations means methods. Then we'll be looking at, or we will be using some other words which are very similar to data and attributes. Okay, this is what I told about the object. Object means it is a real world entity. Okay, now come to the definition of a class. What's a class? A class is a blueprint. We must remember this. A blueprint, or it can be also called as a prototype, that defines the variables and methods common to all objects of a certain kind. Here
we are using these two words, right? Variables and methods, right? Variables and methods. Variables means attributes, methods means operations. Here we got three different words here, right? One is data, and the second one is attributes, both are same, and the third one, which is a variable. These three are same, and methods and operations are same. Now this is the difference between a class and object. You may be wondering, I said object has attributes and operations. Class also has attributes and operations. Then what is the difference between a class and an object? You know, a class is just a template. Have you ever heard the word template? You know, template means it's not a real thing. Here I'm writing template. A class is a template, means it is just an idea, you know, an abstract idea of certain thing. For example, in this example, you know, this is the plan of a building. Is it a real building? No, actually this is just a plan on a simple paper. This is not really existing, but this is just a plan. So this is a template, that's what we say. Now what is an object? Object means a real world entity. So what is this? It is a house, right? Since it is a house, it is really existing. But what about this? On the left hand side, here it is a plan, it's like a template. So what we do is, first we create a class and then we create an object. This is what we do in Java. What we do, first we create a class, and then based on the class we can create number of objects. Then those two things already discussed, and now we see data abstraction. Just now I told you one example of abstraction. What is abstraction? Abstraction means hiding the internal implementation details. That's what abstraction means. Here we see the definition of abstraction. Abstraction is to represent the essential features to the outside world without representing the background details. What does it mean? It means the same. We are showing the essential features. We are showing the essential features. Then, what are those essential features? Just the outlines. We show the outside world just the outlines, not the details, right? Not the details. This is what abstraction means. Now here, without representing the background details. So background details means internal details. We are not showing the internal details, but what we show just the outlines. Abstraction focuses on what the object does instead of how it does. See, I have changed the color of what and how. These two are, you know, two different words, right? Then what the object does, what it is doing, in just an outline we will tell. How it does, the details, right? So abstraction focuses on what rather than how, means it just gives the outlines, not the details. Then, to understand this concept of abstraction, let us see this example. Uh, in programming, real programming, it is the separation of interface and implementation. Here we see two different words. One is interface, and you know, second one is just the, you know, implementation. These two are two different things. Now let's take an example of a computer. We all know about computers, right? Which you can turn on and off. Yes, there is a switch in the cabinet, which by pressing on which you can switch on the computer, and at the same time by pressing on the same switch you can switch off the computer. and you can plug in on USB or pen drive, you can plug in, or you can adjust the volume of speakers. But do you know what actually happening in the inside of a computer? No, right? We do not know how it receives the signals through a cable, how it translates the signals, and these things we do not know. But what we are doing, we are simply pressing the on and off button, right? We are pressing the buttons, that's all. And internal details we do not know. That is the example of separation of interface and implementation. Now, so a computer separates its internal implementation from its external interface. So, what is external interface here? What do you mean by interface here? Here, a switch on button or volume control, like that. These are external interfaces, right? Now, what is the actual implementation? The real work done by the computer. So here internally what is happening we do not know, but externally we can press a button or we can increase the volume. This is what we call in a simple terms to understand data abstraction means. Now let's come to programming. Here, abstraction separates code into interface and implementation. Here, once again, we are using these two words. What are these two words? One is interface, and the second one is implementation. One is interface, and the second one is implementation. Now, these two are the two different words. Yes. What is interface now? So this is interface. Void display. What it displays, we do not know. See, this is where we give just the outline, just the interface. Void display we are writing. What we are going to display? Whether to display a circle or a square or a rectangle? No, we do not know anything about what it actually displays, right? But here this is what we call uh, implementation. So mm, this is interface, and this is implementation. Interface means void display. We don't tell what this display is doing here, but implementation, yes, we write some code here. That's what I included, these curly brackets, right? These curly braces I used, and this is the implementation. Next, encapsulation. What's encapsulation? Here it is the definition: wrapping up of data members and methods together into a single unit is called encapsulation. Wrapping means, it is just like a packaging, right? Packaging up of data members and methods. Once again, what are data members and what are methods? Here see we see data members, and here we see methods. What is an object? Object is a combination of attributes and operations, right? Then here data members means attributes. Okay. Then here methods means operations. See how many words we are getting. Wrapping up of attributes and operations together into a single unit is called encapsulation. Okay, just remember this definition. Encapsulation is a technique used to protect the information in an object from another object. So what is the use of encapsulation? Lot of protection. How can we protect? Then if you create an object, or if you create a class, generally their attributes and operations, right? We write attributes and operations into a single packet. So other objects, methods, may not access the methods of or the attributes of this object. We can do like that in programming. So this is the advantage of encapsulation. Now, this is the meaning of the words I wrote here. Encapsulate means enclose something in or as if in a capsule. Enclosing something in a capsule. What is capsule? A small case, especially round or cylinder one. To understand the concept here, I drew one capsule like shape. Then, what is there inside this capsule? Encapsulation means attributes and operations. Remember, I'm using these words, interchangeably. Attributes means variables. Operations means methods. How do we write variables? So these are the variables. You all know C and C++. Height and weight and color. This is the data type, and these are variable names. What are these? These are methods. We do some action here. In the previous class, we took one example, right, of a table example. A table has certain attributes and a table has certain operations or methods. What attributes table has? Height, weight and color. So we can cut a table, we can paint a table, like this. A table can have these methods. So this is what encapsulation means. Encapsulation means packaging of attributes or variables and methods or operations into a single unit is called encapsulation. Now let us see the code. See, class. In a class we write attributes or variables and plus methods means operations into a single unit. So this is a single unit which is called a class. Now declare a class called car, speed and model of the car you write here. Then these two are what? These two are variables, or you can say that this is, you know, these are variables, and at the same time, these are, methods. These two are methods. Into a single unit, we are packaging these into a single unit. It is called encapsulation. Next concept, inheritance. We all know the meaning of inheritance, right? Inheritance is the property or the process by which objects of one class acquire the properties of objects of another class. What we do here is we declare a class first, and then we will create some other classes based on the above class or parent class. In object-oriented programming, the concept of inheritance provides the idea of reusability. So, what is the main use of inheritance? The main use of inheritance is reusability. We can reuse the code. We need not write again and again. Just we create a basic class first, base class first. Then based on the class, we can create number of subclasses. So here, this is what we call generally called, inheritance, creating a new class, creating new classes from an already existing class. What we do, we will reuse the same attributes and operations of this class in some other classes. This means that we can add additional features to an existing class without modifying it. Here, this class, parent class, has some attributes and operations, right? And here the child class or the subclass can add some other features, extra attributes and extra methods to already inherited attributes and inherited methods. Here we see one example. Here a vehicle is a class. This is a class, and what are these? Model and engine. These two are attributes, right? The other name for attributes is variables. Then here drive and apply brake. What are these? These are methods. The other name for methods is operations. By the end of this class, you all should be well versed with these words, methods, operations, attributes, variables. You should all know the meanings of these words. Now this is the base class. What we are doing, we are creating three more classes based on the this parent class. Now what we can tell is here, the all the attributes and operations of this vehicle class, they can be derived by this bus. Okay, then this bus derives all the attributes and operations of the vehicle. What are they? Model, engine. So bus also has model, engine, and bus also has drive and apply brake operations. So these attributes and operations, they're all derived by these three classes. And remember, in extra, these classes, the bus class or car class or truck class, can add their own attributes and methods, operations. That is the advantage of inheritance. We can reuse the code. Then comes the concept of polymorphism. Actually, this polymorphism is a Greek word, right? It's a Greek term. We all know that poly means many, right? Morphing or morph means forms. So many forms. So many forms. Then here it means the ability to take more than one form. So, sorry, spelling mistake. It's only one form. An operation may exhibit different behavior in different instances. In different instances, operation exhibits different behavior. We'll see here in one example. Here, there is a class called shape. The class called shape. Draw is a method here. Draw is a method, and here this draw, it's a method, and three classes or three objects are created from this class. One is circle object, box object, triangle object. Then this draw, is inherited here, is inherited here, is inherited here. In three objects we have the same draw method, but method name is same, but the action, but the work which this method is doing is different. Here when you call the draw method in circle object, it is going to draw a circle. When we call the draw method of box object, it draws a box. When we call the draw method of this triangle object, it draws a triangle. Now, what does it mean? Many forms. Polymorphism means many forms, one interface, and many forms, many implementations. One interface, many implementations. What is one interface? Draw, and the implementation is different. I think you know the difference between these two words. One is interface, and the second one is implementation. Okay, now this is what we call interface, and this is what we call implementation, right? Implementation, and this is implementation. This is implementation here. Next comes the dynamic binding. What is binding? Binding means linking a call to the code to be executed in response to the call. So procedure call or function call, in Java we call a function as a method. So this is calling, and you know the code to be executed. So these are linked in the runtime, not at the compile time. In the runtime means when the program is getting executed, then a function call will be linked with the function or method definition. Then it means dynamic binding means that the code associated with the given procedure call is not known until the time of the call at runtime. This is what I wrote here. So during the runtime, what method should be called? No, that will be decided at the runtime. It is really associated with polymorphism and inheritance. So we will be writing programs. You need not worry, but we will be writing programs related to polymorphism and inheritance. There you will clearly understand what this dynamic binding means. Then lastly, message passing. Here we create objects. In Java, everything is an object, right? Objects communicate with each other or one another by sending and receiving information, much as people pass messages to one another. So one object can communicate with some other object. A message for an object is a request for execution of a procedure, and therefore will invoke a function in the receiving object that generates the desired results. Here, message means here we call a procedure or we call a function, and it invokes the function of the receiving object. Okay, then the message passing involves specifying the name of the object, the name of the function, and the information to be sent. So we will be writing some program. So there you can see clearly what this message passing means. Here object A, here it is sending some information or message to object B. How do we pass? We pass a message. Then how can we really write the code? We will see in the programming example. Okay, thank you.